All right, section 4.3 is dividing polynomials. Remember, section 4.2 was adding, subtracting, and multiplying. I told you those were pretty straightforward. But dividing polynomials, we have two options. We can use long division, which we're going to use at the beginning, and we're going to use that when we have non-binomial terms. I'm going to start you off with the binomial first to show you how you should do it. Then we'll use an example that they have. And we go from there. All right. And then we're going to find when we do have binomials, if as long as there's a coefficient of 1, we can use what's a simple thing called synthetic division, which will actually help us when we completely factor, which we'll do on Monday. So let's go ahead and get started. To divide a polynomial by a polynomial, you can use a long division pattern. That long division pattern that we learned, 7th, 8th grade. All right. So we're going to divide x cubed minus 8x squared plus 4x minus 9 by x minus 4. So we're going to make our little box that we used to do. All right. And we're going to put x cubed minus 8x squared plus 4x minus 9 down below. And then we're going to put, it's being divided by x minus 4, so we're going to put that on the outside. All right. And let's go ahead and remember what these are called. So let's see. The x minus 4 is called the divisor. The thing that is being divided is called the dividend. And our answer is always going to be called our quotient. All right. So remember, kind of what we did when we had numbers, we just said what number times x, or in this case, would give us x cubed, or in this case, it's a variable. So what variable, x times what, would give us x cubed? And you should be able to tell me that would be x squared. So now what I like to do is I like to put whatever the term is above the same exponent that is in the dividend. So we just said x squared. So I'm going to put the x squared there. And then I'm just going to say again, x squared times x, that gives us x cubed. All right. And now I'm going to do the same thing for the 4. So x squared times negative 4, that gives us negative 4x squared. And then remember what we did when we had these long division patterns. What we did is we subtracted them. All right. And I put my subtraction in there in a circle, and I'll show you why here in a second. All right. And now x cubed minus x cubed. Again, our goal is the first one should always go away. So x cubed minus x cubed is 0. So that does go away. Now on the other one, it says negative 8x squared minus a negative. Negative 8x squared minus a negative. Minus a negative is a positive, so that gives us negative 8x squared plus 4x squared. And that would give us, if we add those, we would get a negative 4x squared. And then remember what we did when we couldn't do anything else, we had to bring the next thing down. So we're going to bring down the plus 4x. All right. And I'm going to do the same thing. X times what gives us negative 4x squared. And you should be able to tell me that's going to be negative 4x. Negative 4x minus, negative 4x times x gives us negative 4x squared. Negative 4x times a negative 4 gives us a positive, negative times a negative is a positive, 16x. And again, we are going to subtract those. And our first ones go away again. And now I have 4x minus a positive. So 4x minus 16x, which will give us negative 12x. And one more time, we're going to bring down the next one, and that will give us minus 9. And one more time, x times what gives us negative 12x? And you would tell me minus 12. And so negative 12 times x is negative 12x. And then negative 12 times a negative 4 is a positive 48. And again, we're going to be subtracting those. The first ones go away. And now I have negative 9 minus 48, which will give us negative 57. And this is our remainder. And when you're done, you put your remainder over your divisor. So on this one here, what you would tell me is, so our x cubed minus 8x squared plus 4x minus 9 divided by x minus 4, well, that just equals our quotient, which is x squared minus 4x minus 12 plus our remainder, which is negative 57, and we put the remainder over the divisor, which was x minus 4. All right. I know that in middle school you use the big letter R. Well, if you put a letter R in Big Ideas, it's going to mark it wrong. It wants it over the divisor. All right. So that's the one I gave you. Now I'm going to give you the one that is similar to some of the homework problems. Again, and it says if any terms are missing in the dividend, include a coefficient of 0 for that term. All right. So we're going to again do the same thing here. So we're going to have our little divisor thing, and we're going to say 4x to the fourth. There's no x cubed term, so we're going to put plus 0x cubed. All right. And then we're going to put plus, well, we don't have a squared term either, so plus 0x squared. We have an x term. And then we have minus 4. All right. And I would even suggest if the divisor has a term missing, you might want to put one in there too, because that would also help. All right. But our divisor on this one here, we have x squared minus 3x minus 2. And again, we're going to just do the same thing. So x squared times what will give us 4x cubed, 4x to the fourth. And you would tell me that would be 4x squared. And if we do that, we'll get 4x squared. 4x to the fourth, excuse me. We'll have negative 12x cubed. And we'll have negative 8x squared. Again, we're going to subtract those. So the first ones go away. 0 minus a negative would be 0 plus 12x squared, cubed, so that would give us 12x cubed. That'll give us a positive 8x squared. And then again, bring down the last term, or the next term in this case, plus 5x. We're going to do the same thing. X squared times what gives us 12x cubed? You would tell me it would be a positive 12x. All right. And if I work all those out, I'm going to just go ahead and write them down for you. 12x cubed, we'd get negative 36x squared, and we would get minus 24x. Again, we're going to subtract those. The first terms go away. And we have 8 minus a negative, so 8 plus 36, which would give us 44. X squared, and 5 plus 24 would give us plus 29x. And one more time, we're going to bring down the number. And let's do it one more time. X squared times what gives us 44x squared? You would tell me it would be plus 44. Again, I'll do the multiplying for you. That'll give us 44x squared minus 132x and minus 88. I'm going to subtract those. First ones go away. Then I'll have 161 x, and then I'll have negative 4 plus 88, which would be plus 84. Okay, now you can be done, ladies and gentlemen, when you see that your exponent on your remainder, remember that's understood to be to the power of 1, is less than the highest exponent of your divisor. So we're done here, and let me write that down for you. I just said our remainder is 161x plus 84. Since our x is less than our x squared on our divisor, we can stop. So our answer is equal to, again, our quotient, 4x squared plus 12x plus 44. And again, with our remainder, which is 161x plus 84, and that will be all over our divisor, which again is x squared minus 3x minus 2. All right, so that's when we are using long division, and you will have a long division problem on your test, of course. All right, and we're going to see that synthetic division is an easy one to use when we have a binomial. Remember, a binomial is two terms, and so on this one here, it's saying a binomial of the form x minus k. On the first one here, I'm going to go step by step with you. On the second one, since we'll see how to do the step by step, we can see how easy we can actually do it. All right. So example 2 says use synthetic division to find 2x cubed minus 5x squared plus 5x minus 2. And we're going to divide that by the binomial of x minus 1. So step 1 says write the terms of the dividend so the degrees are in descending order. I think on your homework, most of it will be in descending order. But if it's not, make sure you're going from the highest exponent to the smallest exponent, okay? And then what we're going to do is just write down the coefficients. Again, if any terms are missing, use the coefficient of 0. So in this case here, we're going to say 2. Our coefficients are 2. we have negative 5, we have 5, and we have negative 2. All right, because there weren't any missing terms. All right. So then we're going to write the constant k of x minus k to the left and bring down the first coefficient as shown. So remember, up above our constant was x minus k. So remember, we have x minus 1. And remember, that's the same as x minus k. So if you think about it on this one here, our k is equal to 1. So we're going to, again, write that down. We're going to write down our coefficient of 1. And then we're going to put this little box here. And we're going to put our coefficients here. So our 2, our negative 5, our 5, and our negative 2. And I always like to put a line in between the 5 and the negative 2 in this case. So the last two terms. And you'll kind of see why I put that in there in a second. So let's go ahead and write that down. Put a line between last two terms. And then it said to bring down the first coefficient as shown. So we're going to put it right there. All right. So now we're going to multiply and add as shown. All right. So let's go ahead and write this down one more time. So we have the 1. We have the 2, negative 5, 5, and negative 2. I told you to put a line in between. All right. And now bring down the first term. And now we're going to multiply and add as shown. So we're going to multiply 1 times 2. And then we're going to put that here. So that would be 1 times 2 is 2. And then we're going to add. And negative 5 plus 2 is negative 3. We're going to do the same thing. We're going to multiply 1 times negative 3. And that will give us negative 3. And then we're going to add those. And 5 plus a negative 3 is 2. And we'll do it one more time. 1 times 2 is 2. Then we're going to add them. Negative 2 plus 2 is 0. All right. So the 1 in the last one here is our remainder. And if it is 0, it tells us x minus 1 is a factor. And we're going to see that's going to be important to us on Monday or on whichever day this is. All right. So for 2023, it is on a Monday. I don't know what it'll be next year. All right. So what you need to think is, again, if I have a remainder of 0, then I don't have to put anything as over the divisor. All right. But I want you to think now this year, we're just going to see our beginning, we had a cubed. All right. What we'll find out is that our next one, our answer should always be 1 degree less. And if you think about it, it does work because this here is my constant term. This here is my x term. and this here is my x squared. Again, our remainder in this case was 0. All right. So on this one here, we'd be able to say that our, what do we start with? We started with 2x cubed minus 5x squared plus 5x minus 2. And again, that was divided by x minus 1 is equal to 2x squared minus 3x plus 2. And again, there was no remainder, so I don't have to put anything over the divisor. And that's our answer on that one. So again, I showed you kind of how to do it. Now I'm going to give you another one. And I notice how I didn't give you as much room because we don't need as much room because we're going to do all of the steps at once. So on this one here, we're going to use synthetic division again to find it. So we're going to, again, take and put our coefficients. So we have 1 for x to the 4th. We have 2 for x squared. We don't x cubed. We don't have an x squared. So we're going to put a 0. Then we have our x term, and then we have our constant term. All right. I told you to put a thing between them, right? And let's see, what else did I tell you? We are going to put, well, remember on this one here, the easiest thing to think is we have x minus k, right? So we have x plus 6. Well, to get it to be minus, we would have x minus a negative 6, right? So that would tell us then that our k is equal to negative 6. And we're going to put a negative 6 on the outside. And we're going to bring the first coefficient down. And now we're going to just start adding, multiplying, and adding. So negative 6 times 1 is negative 6. We add those two, we get negative 4. We have negative 6 times a negative 4. That gives us a positive 24. 0 plus 24 is 24. We have negative 6 times 24. That would give us a negative 144. And when I add those, it becomes negative 140. And then we have negative 6 times negative 140, which will give us 840. And we add negative 20 plus 840. That'll give us our remainder of 820. All right, so again, this is our remainder. This is our constant. This is our x term, our x squared term, and our x cubed. Again, it is 1 degree less if you notice it. So we can again just write it down as our answer would be x cubed minus 4x squared plus 24x minus 140. But on this one here, we did have a remainder of 820. And remember, we put our remainder over our divisor, which in this case was x plus 6. All right, one more thing here, ladies and gentlemen, and we'll be good to go. So finally, the remainder theorem states if a polynomial is divided by x minus k, then the remainder is r. R stands for remainder, and it equals f of k. So we're going to just kind of see what it means by that. So we're going to use synthetic division to evaluate f of x is equal to 4x cubed minus 2x squared minus 5x plus 11 when x is equal to negative 2. All right, so to evaluate f of x when x is equal to -2, divide f of x by x minus a negative x plus 2 is equal to, x minus a -2, which equals x plus 2. Because remember, two negatives and not separated by a number become a positive. Now, what they're trying to show you here on this, ladies and gentlemen, is when they tell you when it's just x equals, use that. All right. Don't switch it up because, again, it's on the outside. X minus 2 is on the outside. Because if you think, let's just kind of think how we would have it. So we have x is equal to -2. That would be if we were using the zero product property, right? So we would say that x plus 2 is equal to 0. So if you think about it, again, to write it as x minus k form, we'd have x minus a -2. So k is equal to -2. So again, when they tell you x equals, just use the number. All right. When we have x minus k, then you're going to change the sign. That's the easiest way to think about it. So let's do this one more time. So on this one here, looks like we don't have anything missing. So we're going to take our coefficients. So 4, -2, -5, and 11. And we're going to put our -2 on the outside. And we're going to bring down the first term. So we have -2 times 4, which is -8. We're going to add those. That becomes -10. Oops, I forgot to put my line there. All right. -2 times -10 is +20. Add those, we get a +15. And then I have -2 times 15, which is -30. Add those, and that gives us -19. So this here is our remainder. And when it says to use the remainder theorem, you're just finding what the remainder is. So on this here, you would be telling me, so f of -2 is equal to -19. And that's just a quicker way than just plugging it in. So it says you can check by substituting x is equal to -2 in the original equation. So if we do that, we're going to get f of -2. And again, wherever I see an x, I'm replacing it with -2. Since I'm replacing a variable with a number, I always tell you to put it in parentheses. And I have -2 times -2 squared. I have -5. I'm still an x there. I'm putting it in parentheses, -2 plus 11. If you look at that, then we know we have 4. -2 times -2 is a positive. 4 times a -2 is -8. And then we have -2 squared, which would be a +4. So -2 times a +4. -5 times a -2, well, that becomes a +10. And then we have +11. 4 times -8 is -32. -2 times 4 is -8. -10 plus 11. Again, if you add those up, you see that you still get -19, which is basically the same thing. So they're kind of showing you can use synthetic division when you have a binomial, and it make it a little easier for you. All right, so that's it, ladies and gentlemen. I believe you're ready for your homework. Thank you.